my final answer, not final answer, but here is my final formula that I need to now plug into the calculator. So the way you would do that is do 0.5. You could say 1 divided by 2 if you wanted to, or just 0.5 times 3.5 divided by, then remember, then you hit 18, and then hit tangent, the tangent button, and then hit the equal button. And that'll give you the value of this number so far. And then you hit times 70, and then equals, and then you would get a number that when you rounded it to the nearest tenth, it would be 377.0. Whew! All right, let's do one more. And before the bell rings here, let me see if I can scream out another one. So in this one, so our first one, they gave us the apothem and a radius. And the second one, they gave us only a side. And in this one, they're giving us only the apothem. Are you serious? That's all we have? All that I know about this regular polygon is the apothem is 5, and you want me to find the area of this dude? You can do it. You have the tools. Let me show you how. So let's start out with what I know. Okay, and what I do know is I can find the central angle. Right? I can always find the central angle. That's the easiest part to do. And remember, I take 360 divided by the number of sides. Triangle has 3 sides. So 360 divided by 3 equals 120, and that's 120 degrees, you'll remember. So the central angle here is 120 degrees. And then I can find, when I take this little half of the central angle and bring that out down here, now here's my right triangle. To find the measure of this angle up on top, I take the central angle and divide it by 2. And that's equals 60 degrees. So I know that this top angle here is 60 degrees, and I also know that the apothem that they've given to me is 5, but that is all that I know. Of course, I could figure out 30 because I know that once I see 60, I know the other one's going to be 30 because the sum of the interior angles is 180, but I don't really even need to know that. I can really ignore this. You could use it, but I don't need to know it. Let's use the 60 degree. So let's put a circle around the 60 degree angle. And this is a right triangle, so across from the right angle is the hypotenuse. And remember, this is a radius, and I could figure out what the radius is, but I don't need to know that. All that I need to know is just the apothem. Hey, I already have the apothem, and the perimeter. So all that I need to know is just the perimeter. And to find the perimeter around this triangle, what I'll do is I'll try to find, or I will find, the value of x, the value of half of the side. And once I find x, then I multiply it times 2. That'll give me the length of the side. And then to find the perimeter, I just multiply the side length times the number of sides, which in this case is 3. And that will give me the perimeter. And I can plug that into this formula, and I'm home free. So I need to find x. And we're back here again. I know that this is my hypotenuse. In reference to this angle, I have the adjacent. So the apothem is the side that is adjacent to the angle that I'm doing my trig on. And I want to know what the opposite side is. Let's put OPP over here. All right, so I have the adjacent, and I want the opposite. And so what trig function uses adjacent and opposite? And the answer to that is tangent. And you know what I did? I used a special right triangle to do this one. So I did not use trig. And I will be teaching you special right triangles here in just a minute. Tell you what, here we go. Let's go ahead and I'll teach you special right triangles as we go along. This is another way, which is actually quicker. And you can do this even without a calculator. So let me show you how to solve this kind of problem when you have a 30, 60, 90 triangle with a special right triangle. And the pattern that I will teach you in the next video after this is that a 30, 60, 90 triangle is 1, 2, square root of 3. 1, 2, square root of 3. So you may not make much sense to you, but right now go ahead and copy this down. This is your pattern of a 30, 60, 90 triangle. 1, 2, square root of 3. And we have, what is it? We have the adjacent side here. We have this, not adjacent. We have the apothem. And we want to find this side, the x. So let's set up a proportion. And did I even do this? What's going on here? Yeah, here it is. Here's up here. So here is my proportion. So I have x over square root of 3. So because these two triangles are similar with each other, they have the same shape and proportional sides. So I can create a proportion between corresponding sides. So here's x that I want. So x is up on top. And the side that corresponds to x is my square root of 3. So x over the square root of 3 equals, and now here are two sides, two corresponding sides that I do know the length of. So 5 over 1. So x over square root of 3, x over square root of 3 equals 5 over 1. 5 over 1. So there's my proportion that enables me to be able to solve for x. So I could have used trig, but it's actually easier to be able to use these special right triangles, and I will teach you how to use special right triangles in the near future. So here's my proportion. I want to solve it for x. The easiest way to do that is to clear the denominator of square root of 3, and I do that by multiplying both sides by the square root of 3. And when I do, I get, these on the left-hand side, these cancel out, and I'm left with x equals 5 times the square root of 3. So the length of this half of a side is 5 times the square root of 3. So I want to multiply that times 2. So s equals 2 times x, which is 2 times 5 square root of 3. And when I say 5 square root of 3, that's 5 times square root of 3. And so, therefore, I can say 2 times 5, which is 10 times the square root of 3. So my side length is 10 times the square root of 3. I want to find the perimeter now. The perimeter is the length, the length of a side times the number of sides. So n times s. N is 3. There are 3 sides here. So 3 times, and I plug in my the length of a side down into here. And so the perimeter, the length of the perimeter, is 30 times the square root of 3, which is approximately 52.0. But we don't want to calculate that yet. We want to take this clean, pure number of the perimeter and stick that up into our equation for the area of this regular polygon. So remember, the area is 1/2 the apothem times the perimeter. And the apothem, they told us, was 5. And the perimeter, we just figured that out. So it's 30 times the square root of 3. Bada bing, here we go. So we can solve this. So 5 times 30 is, how much is that? 5 times, it's 150. 150, and half of 150 is 75. So my area is equal to 75 times the square root of 3. That's the most precise answer. But if you wanted a deformed answer, then you would find, you plug this into your calculator. And remember how to do that? Maybe you don't, so let me explain to you. Remember, this is multiplication between the 75 and the square root of 3. So 75 times, and then hit 3, and then do the square root button. When you hit the square root button, it'll give you the square root of 3. But you don't want that, you want the whole thing. So then hit equals, and that'll give you your entire answer. And when you round that to the nearest tenth, you should have 130.0. Woo! These are hard, but very satisfying problems that you are able to do. We will practice this, of course, in class. I look forward to seeing you there, and may the Lord bless you.